Hello folks, we are once again back with this next video of this exercise 7.5. This is the problem number 20, a relatively very simple problem actually as compared to the problems that we have already done. And this problem, when we did the problem earlier, I had told you, that is when we did the problem number 16, I had told you that these kind of problems are going to come again in the exercise, and this is that kind of a problem where we have a linear and some higher power. So whenever we have such thing, we had done there, whenever it is x and x raised to n, that was a problem that we did there. You just multiply so that these both powers will become the same. So here it's x raised to 4, this should also become x raised to 4. So you multiply the numerator and denominator with that particular term so that the powers will become the same. So for example, here we will multiply the numerator and denominator by x cube. As a result, this will be x to the exponent 4, which is the one that is there here. So that's what we are going to do. So here it's going to be x cube dx and x raised to 4 times x raised to 4 minus 1. Now why we did this is because we are aiming for a substitution. We will try to substitute for x raised to 4 so that the whole thing becomes really simple. So let's call u as x raised to 4. So your du will become 4x cube dx, or rather du over 4 will become x cube dx. So that will change our integral. So let's change the integral and see now how it looks. So I now becomes integral of x cube dx is du over 4 for us. Let's have the 4 out. And because x raised to 4 is u, so it is u times u minus 1. Now it's pretty easy because the denominator are those linears. If you could use a partial fraction, then you can your integration is going to be really simple. So let's consider the 1 over u times u minus 1. It's very easy, so we know we can call it as a over u and b over u minus 1. So that's a times u minus 1 plus b times u. When we want to make the denominator as u times u minus 1, this entire fraction multiplied by u minus 1, this entire fraction multiplied by u, this entire fraction multiplied by u. So that's how we have this. So u over u minus 1, here u times u minus 1, which can cancel each other, and therefore we are left with a times u minus 1 plus bu becoming 1. So obviously now we have to get the values of a and b, for which we have to make substitutions. So first, if u is 1, if u is 1, then this vanishes, so you get b as 1 directly. And then if u is 0, then you have this vanishing, so you have a times negative 1 as 1, which means a is negative 1. So you have got both the a and b values. Now let's put the I together. So it is this actually, therefore your integral I is going to be a over plus b over. So that is a for us is negative 1 over u plus b for us is positive 1 over u minus 1 du. Let's separate it. Negative 1 over u du plus 1 over u minus 1 du. So that's minus log modulus u plus log modulus u minus 1 plus c, or rather, yeah, as I always tell you, you can use your own modifications for the log in order to get the final answer. So when we substitute it back, log modulus u minus 1 means log modulus x raised to 4 minus 1 minus log x raised to 4 minus log modulus x raised to 4 plus. As we say, because log has got immense properties, you can use any of these properties and get an equivalent form. So that's all for this particular problem. Quite simple actually. And the next problem is also simple. So with the next problem, let's come in the next video. Thank you.